I got something for you.
You got wafers.
Yep, some Empire wafers to do globals on.
You got an SPT?
Got it for you. We do everything by the book in this lab.
About time. How many wafers?
Got 5 wafers.
5 wafers. We don't do globals on 5 wafers anymore.
Well, we have to do those for Empire. They want lots of statistics.
Well, we'll have to pass this through Dale first.
Okay.
Yeah, well, guys, we got 5 wafers for globals here. How do you want to split them up? I'll take resistors.
I'll take S parameters and tau ABC.
Okay.
Okay, you gonna take the MPNs, Mike?
Yeah, I'll do the NPNs and the caps.
Okay.
See how time it's going to do.
Get the Empire wafers yet?
Yeah, we just got them today.
Great. So when the global's gonna be done?
All those are being requested. Just getting about started.
Hi, Jim.
Hi, Steve. How you doing?
How are the measurements going?
Should be finishing up just about now.
Good. Then I can get the analysis started on the system. While I'm doing that, can you retrieve some curve data for me from Tahoe?
Sure can.
And if there's any test site data also.
Okay. Will you want histograms or statistical data on that?
Just give me histograms.
Good. Okay.
Thanks.
Okay, you can kill it.
He says you can get jump all the time. We don't have that device.
Why? Well, actually, we do. We have got we just can't put that in.
Why not? I guess you won't be showing.
We all finished with measurements?
Yeah, measurements were all done. Have assigned the SPT.
Okay. They got to go back for dice and pick, and then they'll be mounted on modulars.
When do the globals due?
About another week.
Okay.
Okay, thanks, Mike.
All right.
Hi Steve, how's the data going?
Oh, not too bad. How you doing?
I'm going to be out the 4th. Is there any way that you can have your data done a little bit sooner so I can get started?
Yeah, the day looks pretty good. I should be able to have you give you the globals by the text.
Okay, great.
Hey Jim, here's data for one more wafer.
Great. How'd it look?
Looks pretty good.
Okay. Let me take a look at it and see how we do.
Okay.
See you later.
Hi, Jim.
Hello, Mark.
Got a special request. Could you do your data a little bit early? I'm going to be out the 4th.
Say what?
I would appreciate if you could get it done a little bit early.
Sure. I can, Mike just brought me the data. Actually, it looks pretty good from what I started looking at it. And I'll just work a little overtime and get that in.
Okay.
Shouldn't be very hard. Let
Thanks.
me take a look at it now.
I appreciate it.
Hey, Mark. Looks pretty good.
Yeah, how's the EpiDept look?
You can tell Keith, for your and Keith's information, the epi looks like it's thick epi, about 0.741 thickness with a sigma of 0.02. So, and if you look at how it looks to the models, it looks like we'll have to make a 1% adjustment on the capacitance multiplier. So it looks like good data.
Okay, so will you put that in the
I'll put that.
global and I'll pick it up.
I'll put that in the globals today.
Okay,
See you later.
Hey guys, how are those globals coming? Oh, we're just starting to look at the beta now. Oh, good. Never know what you're going to see when you pull beta out. The system that Mark's put together really works well, though. Makes plugging this data a lot simpler. This is the half-by-1 device. And it looks like we got some leakage problems in here. Hey, the process guys strike again. Hey, look at that range of beta. That's about 100 to 350. We're going to have to put in a large distribution on that. I'll pick one of these center ones to set the nominal globals on and set IB in the area so that Mark can use that data, and then I'll pull the RGB data because Mark needs both of those before he can start. So in this globals, then you'll be putting in a distribution, not just the nominal, to represent this. Well, we normally have a 1/3 distribution on the tolerance, and that will cover a good portion of this, but I'll probably have to extend it a little bit to do all this. So it looks like it. But the leakage we don't normally model. So they've got a couple of sites here that look like there's some problems. I'm not sure what the larger devices look like. We can check those too, though. Well, so if we don't actually model them, we have to put something in the notes. Yeah, we can tell them that we are seeing these difficulties with that. Might be pertinent to their particular.
Mark, how's your Sharky coming?
That's looking pretty good.
Ooh, neat colors! Neat colors!
I can see the beams line up pretty well.
Yeah.
So I should be done with another hour or so.
Okay. Well, those guys are always anxious to get the results. Well, what's this? There's something a little bit on the high side here.
Yeah, it looks like we have some high resistance on one device.
Oh.
We'll have to take a look and see what that is.
Oh, it looks like it's coming along very nicely. The T1, V2 device, the 1x2, shows that same beta spread. So it's not just a small device phenomenon. So we will have to model that distribution, it looks like. Okay. See, that's a little larger device. Yeah, it's a 1x2. They should have no trouble making that in the line. It's not a problem. Usually the half-by-1 will see leakage problems, and you can see it's pretty well cleared up here from this one site. So, pretty much, yeah. Okay, we'll have these out by the end of the day. Alrighty. So Bart, you're pulling some data on the 6000 here?
Yes, I am. I've just uploaded data from the RISC to TSO. I use TSO to analyze my data. And I'm looking at an AXL PNP, and it turns out that there's a serious problem with the data.
Oops.
Yeah. These PNPs, we expect a beta of around 20, but it's coming out to be 1.
Good, good.
This is not the metal contact, right?
No, this is the poly contact.
Right. Okay, so you're gonna have to.
So we're going to remeasure, I think, the way.
The guys in the lab are really, really happy to hear that, Bart.
What can I say?
What can I say? Well, okay, that'll cost us a little time then.
Yeah. Well, these things happen.
Yeah. Okay. You'll let me know what the outcome is.
Yeah.
I can't believe they really turned a poly contact into metal contact. Yeah, we have to get to the bottom of what's going on.
Right.
So how do the models and globals look on the RISC 6000?
Well, they look very good. I've compared both all the NPN, PNPs, and other models and globals and some small circuits which I've run, and they compare exactly on both RISC and mainframe.
Okay, good. I'll do my final check then, and we'll send them over to the product design.
Sounds good.
Okay.
Don't want an AC ground anywhere, no. I guess an AC ground here is what I want. No, it's different.
Okay, I'm doing the final check on the globals now. Each engineer gives me a sheet that has what he intended to make, the changes he intended to make in the globals, and I check that sheet to make sure that the changes do indeed get into the global. After that, I do one final check to make sure there are no syntax errors, and also just to make sure it runs and gives reasonable results. And the final thing that I do is I call product design or send them a note and tell them the globals are ready and tell them where the data set is. And then they go and make their runs and hopefully give us some feedback and tell us what the results look like. And that's basically how we do globals. Hey Mike, we have 5 more wafers to do globals on.